Okay, hello class. Let's go through worksheet 3 together. Alright, I've uploaded the solution on PDF lah, right? So if you guys just want to see the solution, right, you can just look at the PDF. Okay, alright. The video is so that you guys can understand, right, the thought process, right, when we are doing the problem lah, right? Okay, so question 1, two forces, 80 newtons and 60 newtons, they act on an object with an angle of 50 degrees between them. Alright, so I instructed you guys to use the parallelogram method because, okay, the two vectors, right, they are acting on the same point, right? They start from the same point, right? So, a scale of 1 cm to 10 newtons, okay, reasonable scales, right? For some of you guys, you all can consider 1 cm to 20 newtons, right? I think that's fine also, right? Your diagram will be smaller lah. Okay, so you can first draw the 80 newtons one because it's horizontal, right? Your force B is horizontally, it's easier to draw, right? Followed by 60 newtons, okay, right, 50 degrees, and then after that you guys draw the parallelogram. Okay, you realize, right, okay, the dotted lines, alright, okay, they are the imaginary lines lah, alright, because your actual vectors are here. Okay, alright, so you can see that the resultant vector, alright, is also a solid line, right, because this is the what is actually occurring. Okay, the imaginary line is to help us draw the parallelogram. Okay, so in the end you should be getting 126 newtons, okay, 21 degrees anti-clockwise from force B, right, like that. Okay, now for those who are interested, okay, vector resolution, how do I use mathematics, right, okay, to do these kind of questions lah. Okay, so take note of the symbol, alright, okay, we call them vertical component and horizontal component, so we do not call them vertical force and horizontal force because you are resolving the initial force into its component. Alright, okay, just remember that the force, a force and an angle can be resolved into its horizontal and vertical component. Right, Pythagoras theorem, right, at the end of the day, right, I can get back with the vertical component and the horizontal component, right, I can get back my initial vector. Okay, right, so thought process, alright, I take a look at force B is in the horizontal direction, there is nothing to resolve, right, everything is in the horizontal direction, there's no vertical component. Okay, followed by force A, right, because it's at an angle, so I need to resolve it into its horizontal and vertical component. Okay, so how do I resolve it? Okay, we take a look at the left column first. Okay, 60 Newton, I know it's 50 degrees. Okay, so I can resolve it into the vertical component and horizontal component, okay, using trigonometry. Alright, so 60 cosine 50 for the horizontal one, and then after that 60 sine 50 for the vertical one. Right, and as a result, right, we get the following, right, we get the following. Okay, and why do I want to do vector resolution? Okay, it's because, right, I know that for a parallel vector addition, right, everything is very simple, right, I just add them up, right, I just add them up or I just subtract them, right, I don't need to think about the angle because parallel, alright, so I have a vertical component. There is only one vertical component, so the resultant vertical component acting, okay, the resultant vertical component acting, okay, on the object, alright, will be, okay, 60 sine 50, right, because there's only one force. Okay, horizontal component, I have two, okay, that's why I add them up, okay, they are in the same direction. Right, they are in the same direction towards the right. Okay, so I will get 118.567. Okay, once I have my resultant horizontal component and resultant vertical component, right, then this is what I can do over here. Right, this is what I can do over here. Okay, and I can use the Pythagoras theorem to find the resultant force. Alright, okay, so this one we call your Sec 2 math. Alright, and then you should be able to get 127 newtons. Alright, and then after that the theta, okay, the angle, right, you should be able to get 21.2, which is roughly the same, okay, as your graphical method, right, as your scale drawing. Okay, alright. So for vector resolution is more accurate because you are using mathematics, right? You are using calculator as compared to scale drawing. There might be some plus minus, right, 0.1 cm, that kind of difference lah, right, depending on the thickness of your pencil. Okay, I give you some time to absorb you don't need right? Okay, you can just pause the video. Okay, so for question 2, okay, you have a submarine, alright, and then after that I ask you guys to use the head to tail method. Okay, so scale 1 cm to 2 km. Okay, this is the head to tail. Alright, this is the head to tail. Okay, I don't think there should be much issue. Okay, so just take note of the direction. Alright, so 10 km is, alright, you just draw one straight line. Okay, the 30 cm, okay, the 30 degrees, okay, is the one that you all need to take note of, right? So you need to use your protractor, alright, scale drawing of 25 km, and you will get your resultant, right, using the head to tail, right? Take note, head to tail, this means that the resultant, okay, it start from the tail, right? It start from the tail of vector 1 and at the head of vector 2. Okay, tail of vector 1, head of vector 2. Alright, then so you draw like that. Okay, alright. Now then can some of you guys will ask, right, can I use the parallelogram method? Right, yes, you can. Okay, so the parallelogram method works too as well, right? The thing to take note of will be the angle. Okay, alright, the angle, okay, it has to be the same. Alright, it has to be the same, okay, comparatively, right, to the original position. Right, so you look at the 30 degrees, right? You look at the 30 degrees here, right? So this means that when you are shifting, okay, this whole vector, alright, okay, to such that it is at the starting point, okay, this thing has to be 30 degrees, right? Okay, the vector arrangement, right? Sorry, let me look at the video. The vector arrangement, right, need to be the same, alright. Okay, so parallelogram method, you should be able to get the same answer. Alright, remember the diagonal, right? So you draw the diagonal. Okay, you draw the boxes first, then you draw the diagonal. Okay, at the end of the day, you should be able to get the same answer. Okay, now, we continue with question 3. Alright, so this is the question that I think many students ask me, right? Either face to face or email. Alright, so let's take some time to go through this. Okay, so first thing first, right, is that identify the vector that you are being given, right? So what do I know first? Okay, firstly I know the wind blowing. Alright, this is the vector that I know fully, meaning I know the direction, I know the magnitude, right? 90 km per hour north south, so I know it's a vertical vector. Okay, then after that I have my wind speed. Okay, it is 200 km per hour. Alright, so I know that it is an angle, but I do not know the angle. Okay, I know the magnitude, but I do not know the angle. Okay, and then thirdly, it will be the resultant vector lah, right? The resultant direction at which the airplane is moving, which I know the direction, but I do not know the magnitude. Right? So you realize this. For the wind vector, I know both. Right? I know both direction and magnitude. For the airspeed, I know the magnitude, I do not know the direction. Okay, resultant vector, I know the direction, but I don't know the magnitude. Wow, then how to do? Okay, right. So firstly, the scale first. Right, 1 cm to 20 km per hour. Okay, you can put 1 cm to 40, 1 cm to 10, but that will be too big also. Okay, so train of thought. Okay, so train of thought. Okay, we can do the mini diagram first, right, to help you visualize what is going on. Right, so roughly should be like that. Right, airplane, then after that the wind speed, and then after that I will have a resultant direction. Okay, mini diagram help me to visualize a bit. Okay, so what do I do? Okay, firstly I draw a straight line. I draw a horizontal. Alright, so this is what I call the horizontal reference. Okay, something to serve as a guide. I draw a horizontal reference. Okay, any position on the horizontal reference, right, I put a point here. Okay, you can put it anywhere. You want to put it here also can, right? You want to put it here also can, up to you, right? So long as it's at the horizontal, okay, is at the horizontal reference. Okay, so I put it here. Okay, right, I start with what I know fully, right, which is the wind speed. Okay, so I draw. Alright, okay, alright, I know my scale is 1 cm to 20 km per hour, so my wind speed here will be 4.5. Right, so I draw vertically down 4.5 cm. Okay, and then, okay, I ask myself, okay, what is next? What is something that I know the magnitude of, that I can play with, right? That will be the airspeed, right? The airspeed is 200 km per hour, 10 cm. Okay, so what then do I do? Right, because I know my resultant vector, right, is this. But I don't know the magnitude, so I cannot touch it. Right, I can't touch it, right? But I know the magnitude of the airspeed. Right, so what can I do? I use a compass. Alright, so remember, right, we did in class, right? I use the compass, okay, 10 cm. Alright, I draw 10 cm such that it touches the horizontal reference. Okay, why can I do that? Because I have my vertical component here. Right, I have my vertical vector here. Alright, I use the compass, I draw 10 cm to hit the horizontal reference. Okay, alright, okay, for some of you guys can use the ruler also, but that means that you have to try and error lah, right? Because is this 10 cm? Is this 10 cm? Right, I don't know, right? I only know I need to keep on drawing until it hits here lor. Alright, okay, 10 cm. Okay, then that is where I can draw the resultant velocity. Okay, alright, okay, so we start again. Okay, horizontal reference. Okay, you can put any point here. Alright, you can put here, you can put it here. Alright, so Mr. Pang will put it here. Okay, vertical vector, right, of your wind speed, okay, 4.5 cm. Alright, using the compass or the ruler, alright, you draw the slanted line such that it is 10 cm, alright, and hit the horizontal reference lah. Alright, okay, right, okay, and then after that you have your resultant, okay, force. You have your resultant velocity. Okay, right, head to tail. Okay, alright, so this will be your airplane, your wind speed, resultant. Okay, but in this case what we are doing, we are working backwards. Alright, we are working backwards because we are trying to find the direction of the airplane speed, right? So we are working backwards. Alright, so even though you are drawing like that, okay, right, even though you are drawing like this, remember that the direction of your airplane is like that. Okay, I draw big for you. Okay, alternatively, some of you guys draw this also, right, perfectly fine. Okay, in this case what you're doing, right, you have your resultant velocity, right, you work backwards right, no, you have your resultant velocity, okay, you have your airspeed, okay, you have your airspeed, right, you do your airspeed first, and then what do you have? You have your plane velocity, right, from here, because you have this, okay, right, then after that you use your ruler, right, here cannot, here 10 cm, right, nice one. Alright, then you can find. Right, then after that, right, you realize that then which angle do I get? Right, some of you guys say, do I get this angle? Do I get this angle over here, or do I get this angle over here? Right, remember, right? Okay, you need to have the angle, okay, that is relative to the, okay, that is relative to one of the directions lah. Right, so in this case, it would be easier in terms of getting the angle from the horizontal reference. Okay, right, so 26 degrees from the horizontal. Okay, if you want, you can also put 64, right, 64 degrees, right, 64 degrees from the wind vector as well. Okay, right, not an issue. Right, but I hope that you all can see the easier angle lah, right, which is 26. Alright, okay. Okay, so this question requires a little bit of thinking. Alright, so alright, I hope that you guys managed to do it. Okay, now the last one. Okay, the last one I intended for it to be a group challenge lah, right, because you have 3 vectors now. Alright, and Mr. Pang never teach you 3 vectors. Okay, but just hope that for those of you guys who want some challenge and all, right, okay, you can try doing this lah. Okay, I have 3 vectors. Okay, the goal is to show you guys that, right, no matter how many vectors I have, the graphical method works. Alright, no matter how many vectors I have, the graphical method works. Okay, so train of thought. Firstly, draw B. Right, because B is horizontal, I don't need to think so much, right? B is the horizontal, you first draw B. Okay, the scale can be 1 cm to 20 newtons. Alright, and then this is the part where it gets a little bit tricky. Okay, I can either draw A or C first. Okay, but I decided that I want to draw A first. Okay, so I draw A 100 newtons. Okay, I draw A 100 newtons, but at what is the angle here? Right, what is the angle here? Okay, we look back, 30 degrees. Right, the whole, because you think about it, you are drawing force B here, head to tail, right? So you need to transfer your force A, right, to here. Right, so you need to transfer your force A to here, so this thing has to be 30 degrees. Right? Okay. Now for some of you guys who are slightly faster, you all can see, right? Actually it's quite similar to the parallelogram. Actually both methods are quite similar. Okay. Alright, so I transfer. Okay, this, then in the end I will get my force B, my force A. Now force C. Okay, when drawing force C, alright, you think about it, when I'm drawing force C, okay, I also need to follow the angle. And that is where I have an added horizontal here to guide me, right, when I'm using my protractor, to guide me, right, to be able to draw force C at an angle of 40 degrees, right, from the horizontal. Okay, right, so the horizontal is very useful. Right, so once I draw force C down, right, then you realize that I use the what? Remember, head to tail, the tail of the first vector that you draw to the head of the last vector that you draw. I have my resultant, and then I get 150 degrees, right, from force B lah. Okay, so at the end of the day, you should be able to get 94 newtons, okay, at 150 degree clockwise, right, clockwise, okay, from force B. Okay, take some time to digest. Alright, now 3 vectors, right? Sometimes maybe a bit hard to draw. Okay, right? When you do not have your drawing instrument, right? Then how? Right? If you do not have your drawing instrument, then what do you do? Okay, now that is where the vector resolution comes again. Okay, right? Same thing. Train of thought. Force B is in the horizontal. There's no need to resolve. Force A and C is at an angle, okay, and therefore I need to resolve it. Okay, alright, so once I resolve it, okay, you realize that, okay, I have a horizontal component for A, I have a vertical component for B. Same thing for 4C, I have a horizontal component and a vertical component. Alright, to make it clearer, alright, okay, using Trigo, I even put the direction there. Alright, so it should be 100 sine 30 upwards, okay, right, and then after that for the horizontal component, right, it will be to the left, right, it will be to the left, okay, and then after that for 4C, right, it will be downwards, right, because 4C is acting, right, slightly downwards, right, so it's downwards and to the left, okay. Now why this is important, right, is because, right, you recall that vectors have direction, and precisely vectors have direction, right, then we need to determine, right, which direction we want to be positive, which direction we want to be negative, right. So if let's say I say, okay, let's set right to be positive, means left is negative. Let's set upwards to be positive, downwards to be negative. Alright. So in this case, right, Mr. Pang has take downwards as positive, left as positive. Okay, for simplicity's sake, right, because I have already done the question, right. So resultant horizontal component, what do we have? The resultant horizontal component, okay, we have from force A, force C, and the whole of force B, right? Remember force B is what? Horizontally, right? Okay, so remember the box, right? Remember the box in your notes. Okay, the box is here, so I have force B, okay, and then after that I have force A, I have force A horizontal, force C horizontal. Then what do? I add them up, right? I add them up. But when I add them up, you remember what I say? I take left as positive. Positive, positive. Force B is what? Force B is to the right. Right? Force B is to the right. So I can, okay, I need to put a negative sign. Okay? Right? I need to put a negative sign. Okay? And in the end, I should be able to get 81.509. Okay? And then I do the same thing for resultant. I do the same thing for the resultant component. Okay, I do the same thing for the resultant component. Okay, then you remember. Then what did I say? Downwards as positive. Right, downwards as positive. Okay, my force A is upwards, no? Right, you see here, my force A is upwards. So it had to be negative 100 sine 30, okay, plus 150 sine 40, I'm getting 46.418. So what is the direction of the resultant component? 81.50 n to the left, right, and then after that 46.418 downwards. So at the end of the day, right, okay, this is what I get. The ball, right, the ball, and then after that I have my horizontal component, I have my vertical component, okay, right, parallelogram method, alright, I can get my diagonal, okay, I can get my theta, okay, right, this is my mini diagram. I'm not going to do the scale drawing, right, remember, there is no, you do not have your instruments already, alright, then I use my, okay, mathematics, Pythagoras theorem, okay, resultant force, okay, resultant force will be equals to the resultant vertical component square plus resultant parallel square, okay, and then after that I'll get this, okay, alright, square root it, I'm getting this, okay, where to find the angle, trigo, tangent, alright, inverse tangent you should get 29.7, alright, same thing as your scale drawing, right, so what to note is that your Pythagoras theorem and trigo is actually more accurate, right, because you are using mathematics, okay, as compared to graphical methods, right. Okay, so we have come to the end of worksheet 3. I hope you find it useful. Alright, any issue, you all can email me, alright, or just let me know face to face. Alright, so okay, have a great CNY.